Thanks very much, and thank you to Rod and the organizers for having me here. So my name's Dr. Matthew Phillips. I'm a neurologist in New Zealand. I'm Canadian originally, and I'm going to speak about neurodegenerative disorders as metabolic icebergs. This talk will be a lot about cause and effect. A great poet once said, "The cause is hidden, the effect is visible to all." And that man was the Roman poet Ovid. Ovid's quote sums up our current approach to neurodegenerative disorders quite nicely, in my opinion. Let's see why I say that. So let's talk about the prevalence of these disorders briefly, which Chris already mentioned. Neurodegenerative disorders were actually rare in previous centuries, but now they are relatively common. So just 5 years ago, Alzheimer's and other dementias afflicted 45 million people. It's closer to 60 million people now. And Parkinson's afflicted 8.5 million people, and it's probably closer to 10 million people now. Amyotrophic lateral sclerosis, or ALS, the most common form of motor neuron disease, probably afflicts around 500,000 people. And Huntington's afflicts another 400,000 people or so in the world. Now, this is of great concern because despite heavy investments into treatments, these disorders are still rising in prevalence. Alzheimer's and Parkinson's are actually doubling every 20 to 30 years, and this is really not sustainable. So rather than carrying on, I suggest we take a pause and consider that much of the problem actually lies in perception. There are other things, but how we perceive these disorders is very important. Our current perception is this. Currently, we classify or split these disorders in healthcare based on three main things: the primary neurological symptoms, the primary neurodegenerative region in the brain, and the primary type of neuron protein aggregate that afflicts the neurons in the brain. So for Alzheimer's, for example, the primary neurological symptom is cognitive impairment and dementia. The primary neurodegenerative regions are the hippocampus and neocortex. The red rectangle there outlines much of the neocortex. And the primary neuron aggregates are amyloid beta and tau. If we look at Parkinson's, the primary neurological symptom is Parkinsonism. So that's your tremor, your sort of rigidity, and your slowness of movement in general. The primary neurodegenerative region is a little thing called the substantia nigra in the brainstem. The blue rectangle is circling that. And the primary neuron aggregate is alpha-synuclein. If we look at ALS, the primary neurological symptoms are limb and bulbar weakness. Bulbar weakness is your sort of swallowing and speaking. The primary neurodegenerative regions are the motor cortex and the brainstem, which the orange rectangle is circling. And the primary neuron aggregate, the protein that's abnormal, is called TDP43. And lastly, Huntington's, the primary neurological symptom is a movement disorder called chorea. The primary neurodegenerative regions are the striatum and the neocortex, which the green rectangle somewhat outlines, and the primary protein is the mutant Huntington protein. So this is how we look at these disorders in a nutshell in the healthcare system today. Now, there are implications to this splitting-based approach. Healthcare is also split into specialties to mirror this. And so what this ends up doing is that each of us as healthcare specialists are sort of restricted to diagnosing and managing within our own level. And I'll use an iceberg analogy to show that. So for neurological symptoms, neurologists such as myself and allied health specialists, we basically do the diagnosing and managing of those. When it comes to the neurodegenerative regions, well, that's the realm, the diagnostic realm of the radiologists. They can see what's atrophied and what's not. And then the surgeons can actually help with some neurodegenerative disorders through techniques such as deep brain stimulation. It's quite useful for Parkinson's. Some of them are trying it in Alzheimer's as well. And then when it comes to the third level, the neuron aggregates, that is the realm of the pathologists. They diagnose the neuron aggregates. And then we have a whole army of researchers that are trying to manage the aggregates. They're trying to suppress or eliminate the aggregates and hope that they make the rest of the neurodegenerative disorder better. So this simple iceberg view implicates ultimately the neuron aggregates, these proteins, as the ultimate cause of these disorders. And the underlying triggers are debated, but this is where we're at today. We're trying to basically get rid of these proteins and see if we can help the rest of the iceberg there. There are problems with this approach. So first of all, this splitting-based approach does not explain why Alzheimer's, Parkinson's, and all these disorders have other neurological symptoms, a lot of other ones. So Alzheimer's has a lot of non-cognitive symptoms. Parkinson's has a lot of non-motor symptoms. ALS and Huntington's have a lot of behavioral and cognitive symptoms that aren't explained by the sort of traditional classification approaches that we use. And also these disorders all lead to neurodegeneration in other areas of the brain, sometimes the spinal cord, sometimes the nerves, the peripheral and autonomic nervous systems. And the aggregates also occur well outside of the primary neurodegenerative regions as well. Second problem with splitting, it doesn't explain why the degenerative changes in protein aggregates actually occur well outside of the nervous system in all four of these disorders. So you've got neuron aggregates affecting multiple organs, tissues, and cells, such as the gut, particularly in Alzheimer's and Parkinson's, such as the musculoskeletal system, so the muscles themselves, all four of them have changes in the muscles, particularly ALS and Huntington's, and the heart, particularly ALS and Huntington's. These things are all affected, and this is just a snapshot. Multiple other organs are also affected. The third problem with splitting is it ultimately facilitates targeted suppressive treatments that are aimed at the symptoms and the neuron aggregates. We try to suppress or eliminate the symptoms and the neuron aggregates and hope that this will somehow improve the disorder and cure it. And I don't think that's ever going to work. Vaccines are the way that we often try to suppress the neuron aggregates. And yeah, I don't think that's going to work. So splitting portrays neurodegenerative disorders as focal neurological disorders in a few parts of the brain. But in fact, they're absolutely widespread multi-system disorders affecting multiple parts of the nervous system and many other regions of the body. So you can't target that. There's an alternative way to perceive this, though. Okay, so we can perceive these disorders by amalgamating them or lumping them rather than splitting them by a shared universal feature of impaired mitochondrial biology. Impaired mitochondrial biology unifies all of them. Mitochondria are the small organelles. There's hundreds of thousands of them in all our cells except red blood cells, and they produce energy, move around the cell, coordinate metabolism, do a whole lot of stuff. And the impairments in mitochondrial biology are multifaceted, so they go beyond. I used to use the term mitochondrial dysfunction, but I'm starting to sway away from that now because there are multiple facets of mitochondrial biology that term does not really encompass. And you can look at mitochondrial biology by 6 levels in order of decreasing complexity. So the first level is mitochondrial metabolism. In the neurodegenerative disorders, you have impairments of mitochondrial metabolism. Metabolism is the chemical reactions in the cells throughout the body. In the second level, mitochondrial phenotypes are the characteristics of the mitochondria relevant to the cell. In neurodegenerative disorders, you have abnormal mitochondrial content in the cell, for example. Third level down, mitochondrial behaviors. These are impaired in neurodegenerative disorders, and these behaviors include things like mitochondrial fusion, so they come together normally, and fission, where they split apart. Normally, motility, so mitochondria move around cells and neurons. They're very mobile. Mitogenesis, so the birth of new mitochondria, and mitophagy, which is the destruction of old junky mitochondria. All of these things are impaired in these neurodegenerative disorders. Mitochondrial function, fourth layer down. So in neurodegenerative disorders, the mitochondria display decreased ATP production, increased reactive oxygen species emission, so free radical emission, all 4 of them. And fifth level down, mitochondrial activities. So there's impaired mitochondrial enzyme activities in the respiratory chain. The respiratory chain is what generates the energy in the mitochondria, and it has 4 main components. So the first, complex 1, is messed up in Parkinson's. Complexes 2 and 3 are messed up in Huntington's. Complex 4 is messed up in Alzheimer's, and all 4 of them are messed up in ALS. And sixth and final level, at the most simple level, mitochondrial features. So you get abnormal mitochondrial shapes and sizes in the neurodegenerative disorders, and you get damage to their cristae, where the respiratory change is located, where the energy is being made, and you also have damage to their mitochondrial DNA. So there's just huge numbers of impairments, multifaceted impairments in mitochondrial biology in these disorders. So it's not a simple thing. And this unifies all of them. They all have this. And if you want to read more about this excellent paper that came out earlier this year by Martin Picard's group in New York discusses the multifaceted nature of mitochondria. Okay, so lumping has implications. Now, lumping neurodegenerative disorders by their impaired mitochondrial biology reveals what I call an entire metabolic iceberg. So we still have the top of the iceberg above the waterline here. That encompasses the neurological symptoms, the neurodegenerative regions, and the neuron aggregates. No problem, it's the same thing. And we can still diagnose and manage those as we have been doing. But there's this huge part of the iceberg that we are not looking at right now in medicine. And these are the lower levels. These comprise the 6 layers of multifaceted impaired mitochondrial biology. This is so huge, and we have to try and look at all of these levels and realize that impairments in mitochondria go far beyond just a simple term such as mitochondria dysfunction. And at the base of this iceberg, of course, why are the mitochondria impaired in the first place? Well, there are various environmental factors. Genetic factors are there too, but they're a minor player in most of these disorders, with the exception of Huntington's. I'll talk about that in a second. But these environmental factors are the things that are triggering the multifaceted impaired mitochondrial biology. These things include industrial toxins, the modern dietary lifestyle, of which seed oils would be a part of that, modern cognitive, physical, and social elements of the lifestyle, which are all abnormal to a degree. Okay, so it's useful to address the upper levels of the pyramid from a diagnostic and management perspective. We still should do that, and we can do that. But if we want to, dare say I use the word cure, or really make a strong therapeutic impact, it's crucial to address the lower levels of the pyramid, particularly the base. And if you do that, there's going to be, in my opinion, a trickle-up effect where you'll actually improve. If you improve one lower layer, you're going to improve all the ones above it, and things will keep trickling up. And of course, we want the symptoms at the top to improve the most. And I think this is the way. It's not an easy approach, but I think it's a more realistic one. Okay, so lumping offers explanations to the problems created by splitting, all of them. So it explains why multiple neurological symptoms occur, and it explains why degeneration in neuron aggregates occur outside the primary neurodegenerative region, because it's all neurons, and neurons are highly metabolically active, and they have a lot of mitochondria, and the mitochondrial biology has to be efficient. So of course they're going to take the first hit when you get impairments in mitochondrial biology. It also explains why other metabolically active cells, such as skeletal muscles and cardiac cells, they take a hit in these disorders too, because they are metabolically active and they have mitochondria that need to be running efficiently too. And finally, this approach, which the thing I love about it the most, is it facilitates systemic restorative therapies. It says we can't target this particular region of the brain or this particular symptom. We have to restore the whole brain and body. This is a systemic disorder. So we need a therapy that actually works on the whole system, the whole human body. So lumping more accurately portrays these neurodegenerative disorders as widespread multisystem disorders, and widespread multisystem disorders need systemic restorative therapies. It's not about targeting and eliminating. So almost all the research studies that are being done right now, I don't think they're going to work. Okay, so let's look at this in more detail. So Alzheimer's as an iceberg. So we can still diagnose and manage Alzheimer's by using medications and allied health strategies to deal with the dementia. In terms of the symptoms, we can still use radiology to try and diagnose the atrophy in the hippocampus and neocortex, and we can still, diagnose with pathologists the neuron aggregates and try to manage them with targeted strategies. Though I don't think that'll work. None of that needs to change, I guess. But if we want to alter Alzheimer's in a systemic restorative sense, what we have to do is start looking at the lower layers of this metabolic iceberg and realize we have to restore the lower layers. And ultimately, that means therapies that alter the environmental factors at the bottom that trigger the impaired mitochondrial biology in the first place. That means for Alzheimer's, certain heavy metals, which are strongly associated with triggering it. That means elements of the modern dietary lifestyle. That means air pollution. That means chemicals and pesticides. They're all strongly implicated in this disorder. Low cognitive stimulation, physical inactivity, so insufficient exercise, and chronic social isolation and poor sleep. All these things are strongly associated with the, Alzheimer's disease, and we can modify all of them. So Parkinson's, we can look at that one. So again, Parkinson's, we can still use medications to try and treat the motor symptoms at the top of this iceberg. We can still use allied health input. In the second level, we can still use radiologists to look at the brain and say, oh, this region's atrophied or that one is. And we can still use surgical techniques such as deep brain stimulation to help improve the symptoms related to that. And we can still use pathologists and to diagnose the alpha-synuclein and so on. But if we want to alter Parkinson's in a systemic restorative sense, we need to look at these 6 layers and try and restore all of them from the bottom up. So these therapies involve, again, altering the environmental factors. For Parkinson's, the strongest ones are certain heavy metals, pesticides, chemicals, the modern dietary lifestyle, physical activity, and social isolation. So a little bit different from Alzheimer's, but a lot of overlap. ALS, same thing. So the limb and bulbar weakness, we can still manage that, try to manage it with medications. We can still try to manage it with allied health input, speech pathologists, and so on. We can still diagnose it to some extent radiologically, and we can still try to use techniques such as gastrostomies and feeding tubes and things to help manage the symptoms that way. The neuron aggregates, we can still diagnose as those as we have. But if we're going to make headway in ALS, we need to manage the bottom of the metabolic iceberg, and that means looking at the things that trigger it, which again are heavy metals, pesticides, interestingly, electrical occupations, so perhaps repeated electrical shocks or electromagnetic fields can trigger it. Smoking, physical activity, and interestingly, excess cardiovascular exercise is a strong trigger for ALS. So yes, exercise can be taken too far if done improperly. So that's important to remember. Lastly, Huntington's. So Huntington's, we can still manage it as we are by trying medications aimed at the motor symptoms, trying allied health strategies. We can still use radiology to look at the changes in the brain. We can still look at the neuron aggregates and diagnose Huntington's by looking at the mutant Huntington protein. But if we're going to make headway in Huntington's, we need to realize that impaired mitochondrial biology is the thing that needs to be shifted and altered and improved, and we can do that. Now, the mutant Huntington gene is there, no question, but a lot of people think maybe that gene creates this mutant Huntington protein that is somehow toxic to cells. Well, it's almost certainly leads to impaired mitochondrial biology, but a lot of that impaired mitochondrial biology, I think, is just because the normal mutant Huntington protein isn't there. You've got an abnormal one, and we can maybe improve the impaired mitochondrial biology through other ways. And that's why I think even a genetic neurodegenerative disorder like Huntington's, we can use strategies to improve that without changing the genetics. So other things that are definitely associated with increased development or progression of Huntington's are the modern dietary lifestyle, low cognitive stimulation, and physical inactivity. Okay, so if we look at treating the entire metabolic iceberg, what we're saying is that impaired mitochondrial biology, multiple facets of it, results from the factors at the base, and those are related to our modern environments and lifestyles. And so we can alter those, and I think we need to alter them by looking big picture, by using strategies that actually induce or optimize something called mitohormesis. And mitohormesis, I think, is the key to doing this. Basically, mitohormesis involves multiple mitochondrial exposures to a challenging but not overwhelming stressor, something they can handle, each of which is crucially followed by a complete but not excessive recovery period. And it's during that recovery period where the mitochondrial biology changes, it's reconfigured, and in a way that allows the mitochondrial population to be exposed to that same stressor or even a higher dose of it in future and come out okay. So this is key. And it's important to recognize it's not focusing on the challenge period or the recovery period in isolation. That won't work, and that's harmful. It's this oscillating balance between challenge and recovery that we're aiming for. So that's why a lot of things that people try, such as exercise, take it too far. Excess challenge, not good. You need adequate recovery. That's just one example. It's the oscillating balance that induces optimal mitohormesis. So that being said, some evidence-based strategies for mitohormesis in the neurodegenerative disorders would be as follows. So environmental factors on the left, challenge phase in the middle, recovery phase on the right. So we know that industrial toxins probably trigger these disorders to a very large degree. So you want to create an oscillating balance between low transient exposures and zero exposures. For dietary lifestyle, we want to have an oscillating balance. I'm glad Mike and Chris both mentioned ancestral diets because I think those create the best challenges. The Western diet, quite frankly, creates an overwhelming challenge for mitochondria and it's damaging. But if you oscillate between ancestral diets and periods of fasting, that is the best way to induce mitochondrial hormesis or mitohormesis. Now, looking at cognitive, physical, and social lifestyles, the challenges periods can all involve periods of cognitive stimulation, exercise protocols done correctly, and social engagement. And this is what the data shows for neurodegenerative disorders, that these things at certain levels can be helpful. But just as crucial is the sleep and relaxation periods. So you need to have these recovery-based strategies that complement the challenge ones if you want to induce mitochondrial hormesis optimally. So a lot of people focus on the challenge phases too much. They focus on ancestral diets, great. Cognitive stimulation, fantastic. Exercise, good. Social engagement, good. But we really need to focus on this side of the mitohormesis chart more, the fasting, sleep, and relaxation in particular. These things are consistently underappreciated, in my opinion, and I think the recovery is where the mitochondrial biology actually improves. The challenge is designed to mess it up. You need to have proper recovery periods if you want to get optimal mitohormesis and health in the long term. This is what I think. Okay, so treating Alzheimer's from the bottom up. I'll just have a few examples now in the last 5 minutes of the talk from some of our own work where we sort of use strategies that would have induced mitohormesis to try and improve people with each of these 4 disorders. So we did a randomized crossover trial of a modified keto diet couple years ago now versus a usual diet with healthy eating guidelines in 26 people with Alzheimer's. So I guess the first randomized trial of a keto diet in Alzheimer's to date. And this, in terms of mitohormesis, we converted an overwhelming stressor, so the Western diet that all these people were on, to a challenging, surmountable one, an ancestral diet. Didn't focus on fasting, but we did say, please don't have snacks, just have 3 meals a day, no snacks at the time. People on the keto diet improved in a powerful way, so statistically significant, but more importantly, clinically meaningful way in daily function and quality of life, which are the 2 things that are most important to people with Alzheimer's. So if we look at the results, I guess, here, blue is the usual diet, red is keto, and up is better. So in terms of cognition, the usual diet, they declined, which is what Alzheimer's does. The keto diet stayed about the same or maybe improved a little. That one wasn't statistically significant. It almost got there, but it wasn't. In terms of function, well, the usual diet, they definitely declined and the keto diet stayed about the same. And in terms of quality of life, the usual diet stayed about the same and the quality of life actually went up in the keto group. So those were pretty powerful results if you want to read that. It came out a couple of years ago now. In terms of Parkinson's, so we also conducted the first randomized trial of a keto diet in Parkinson's as well, and that was versus a healthy low-fat diet. So that was low-fat, high-carb, all sort of natural carbs, and 47 people with Parkinson's for 8 weeks. And in terms of mitohormesis, this actually would have converted an overwhelming stressor, so the Western diet, to a challenging, surmountable one in both groups. One was high-fat, low-carb, one was high-carb, low-fat. So you'd expect improvements in both groups, and that's what happened. So the question is, which one improved more? So people on the keto diet actually improved more in a statistically and clinically meaningful way. So it's not just about mitohormesis. There are other benefits to the keto diet, I think, that went beyond the low-fat, high-carb one. And they really improved in the non-motor symptoms, which are the most burdensome aspect of Parkinson's. There's a whole slew of these so-called non-motor symptoms. And many of the most disabling, least levodopa responsive ones, actually the ones that are toughest for us to deal with in the clinic, improved the most. So that was really cool. So in terms of this one, the blue line shows low fat group and the red line shows keto. Down is better in this case. And you can see that low fat still improved by about 10% in these non-motor symptoms, whereas keto improved by about 40%. So pretty tremendous improvement in just 8 weeks. And that one came out, gosh, I can't believe it's 5 years ago now. So in terms of ALS, we have a paper in review right now. It's still in review. It's just a case study, but it's quite encouraging. We've used a time-restricted keto diet, so moving more into incorporating fasting into our protocols in a 64-year-old man with bulbar onset ALS, the worst kind of ALS, leading to worsening swallowing, breathing, fatigue. And he did this for 18 months, so a year and a half. In terms of mitohormesis, again, we altered his Western diet and we introduced fasting periods this time as well to try and get that oscillating balance between surmountable challenge and adequate recovery. And this study is under review, so I can't comment on it, but it's almost 2 years now and he's still utilizing it, so you can read into that how you like. Hopefully it'll come out soon. In Huntington's, we also did something similar in a 41-year-old man. So a time-restricted keto diet. So again, keto diet plus fasting periods. And he did that for a year. And in terms of mitohormesis, again, this would have improved mitochondrial biology to some extent, one would think. And collectively, he had some really good improvements. His motor symptoms, the chorea, the movement disorder, improved by 52%. There were other motor symptoms that improved too. That doesn't just describe chorea. And his behavior problems, which are the hardest part of Huntington's, the irritability and apathy and so on, those virtually vanished. And that was just after a year on this diet. So if we look at that, blue is baseline, orange is 6 months, gray is 12 months, and down is better. You can see that his apathy scores went way down. His disorientation scores vanished. His anger went down. His irritability went down. And so overall, a 50 to 100% improvement, which is really great to see. He's still doing that, and it's been 2.5 years. And that was published just last year. So to conclude this talk, I just want you to try and go home with a few key points. So I think neurodegenerative disorders are currently split on clinical, anatomical, and pathological grounds. This is how we see them in the hospital today. I went to Westmead Hospital yesterday, and this is how the doctors running around trying to address these things. That's what they're focused on. But and there's no denying that this is useful from a diagnostic and management perspective. That's why those doctors are there. However, we can also lump these disorders based on a single shared universal feature of multifaceted impaired mitochondrial biology, which is very complex, and we're only just scratching the surface of this. And this is the real core disease that we're seeing from the top of the iceberg as all these different things: Alzheimer's, Parkinson's, Huntington's, ALS, whatever. And it's really the same thing coming out in a different way for each of these disorders. And I think if we realize that and really truly address that, we're going to actually make some headway from a therapeutic stance with these disorders. So perceiving these disorders as metabolic icebergs can facilitate this, because it lets us see them in their entirety, and most importantly, what is cause and what is effect. So Ovid would have been happy with that. And if this is correct, strategies that optimize mitohormesis may actually lead to the most real and long-term therapeutic gains in future for people suffering from these disorders. And I hope we get there. Thanks a lot.